Dative covalent or coordinate bonding. This also involves the sharing of electrons, but in this type, the electrons to be shared are donated by only one of the participating atoms. This occurs when one of the reactants has lone pair of electrons and is called the donor, while the other has an empty space and is called the acceptor. Formation of ammonium ion. Ammonium ion is formed between ammonia and hydrogen ion. Ammonia has 3 shared pairs between 1 nitrogen and 3 hydrogen atoms and a lone pair of electrons, while hydrogen ion has no electron, hence an empty space. Ammonia donates its lone pair of electrons to be shared with hydrogen ion as shown in the diagram below. Formation of ammonium ion. This is the ammonia molecule with 1 lone pair and 3 shared pairs of electrons. An ammonia molecule combines with a hydrogen ion that has no electron to give ammonium ion. The ammonium ion has 1 lone pair of electrons donated by ammonia. This is a lone pair of electrons. 3 ordinary covalent bonds and 1 dative covalent bond. Dative covalent or coordinate bond is represented by an arrow starting from the donor atom to an acceptor atom. The formation of ammonium ion can be represented as formation of phosphorus oxychloride. Here is phosphorus with 5 electrons, 1 lone pair there. Here is chlorine. Another chlorine atom. Another chlorine atom here. You have 8 electrons in the outermost shell. Here is oxygen. 8 electrons. So this is a molecule of phosphorus oxychloride. Here we can see the 3 ordinary covalent bonds and the 1 dative covalent bond. Phosphorus oxychloride can be written as formation of oxonium ion. Here we have the hydrogen ion with no electrons combining with a water molecule. The water molecule has 2 lone pairs and 2 shared pairs. Here this hydrogen ion has an empty space and can bond covalently with this lone pair of electrons. So here we have a lone pair donated by oxygen. Here, shared pair, and then another lone pair. So this molecule becomes charged. The formula of the oxonium ion is H3O+. All the 4 atoms have complete outer shells. So this is oxygen, hydrogen, hydrogen, hydrogen. The hydration of copper 2 ions is also due to the formation of coordinate covalent bonds. The copper 2 ions has no electrons in its outermost shell. It accepts 4 lone pairs of electrons from water molecules, that is, 1 lone pair from each water molecule. The blue hydrated ion that results is hydrated copper ion. Other compounds with coordinate covalent bonds are the hexacyanopherate 2 ions and the hexacyanopherate 3 ions. They have a central ion 2 or ion 3 ion surrounded by 6 cyanoions. 4 of the 6 cyanoions are on the same plane. 4 of the 6 cyanoions are on the same plane as ion 2 or ion 3 ions. One of the cyanoions is above and the other below, and the other below the iron, and the other below the iron. In silver diamine ion, the lone pair of electrons in the ammonia molecule forms a coordinate covalent bond, as shown. Compounds containing coordinate covalent bonds have properties very similar to purely covalent compounds. The presence of coordinate bond, however, tends to make a compound less volatile.